This video is going to explain how to use enthalpy with chemical equations. And as you can see, I have a couple of chemical equations here on the page. The very first thing that we need to focus on is this idea. We're going to have enthalpies with each of these problems. If I have a negative enthalpy or a negative heat value, then that means that heat is going out. It is being taken away from the system. That makes it exothermic. If I have a positive delta H value, then that means that heat is going in. So it's endothermic. Those numbers actually matter because they determine what I'm going to do with this up here. The very first thing that I'm going to choose to do is I'm going to rewrite this equation, the chemical equation down below, and I am going to add the 65.2 kilojoules to this equation as if it is a part of the chemical reaction. Well, whether or not it's positive or negative will determine whether I put it over here in the reactants or if I put it over here in the products. Basically, if delta H is negative and it's being given off, then the products are what are being given off. That's what comes out of reaction. So I'm going to put it over here as a product, and notice I didn't write minus 65.2 kilojoules. I wrote plus 65.2 kilojoules because we never put subtraction signs in chemical reactions. It's just understood that these two things are coming out or being given off, and these two things are going in. So had this been a positive 65.2, I wouldn't have put it right here. I would have put it over here on this side. I would have put 65.2 plus CaO plus H2O. The second thing about this reaction that I want to look at is the idea that it's balanced. You can go back and forth and check for just a minute, but I have to have a balanced chemical equation because I'm going to view this like I viewed my other chemical reactions in moles. For example, 1 mole of CaO will produce 65.2 kilojoules. 1 mole of H2O would use 65.2 kilojoules. It just so happens that all of the coefficients in this particular example are 1s. So the question asks me if I have 15.0 grams of calcium hydroxide, how much heat is evolved or how much heat is produced. So the first thing that I'm going to have to do is go to moles, because when I just did this, I was talking about 1 mole of a substance making this many kilojoules of heat. So I'm going to have to convert grams to moles, and I presume as I'm making the video, that you already know how to convert grams to moles, and that you know how to calculate the molar mass of a substance. There are 74.1 grams of calcium hydroxide in 1 mole based on the periodic table masses. Then, once I've got that far, I know that up here there's 65.2 kilojoules of heat produced for every 1 mole of calcium hydroxide. And how I'm getting the 1 is that there's an understood number 1 in front of that. If I stop and I do the math here for these numbers, I will end up with 13.2 kilojoules based on sig figs. Now, here's the other thing. I didn't do anything up here. There's kind of a couple of correct ways to answer this. I can say that there's 13.2 kilojoules evolved, produced, made. I can put words with it that tell me that it was made, or I can answer it as a negative number, that negative 65.2 kilojoules is just simply my answer. I can put the negative in here because it's being given off, and that will give me this negative answer. If I don't put it, then I must have words. So you either need a negative sign and just the number with the unit, or you need, and I wrote the wrong thing there. I wrote the 65.2 kilojoules. I can answer that it's negative 13.2 kilojoules being produced. So I can write it this way, negative 13.2 kilojoules, or I can answer it 13.2 kilojoules evolved or made, one or the other. If you do both, it's kind of like saying that I lost minus $20. I didn't. I either ended up with minus 20 or I lost 20, but I don't put them both. I don't say negative 13 lost or made. Like, that's just it's redundant. Let's go on to the next problem, which says how much heat is generated if 5.67 moles of product are formed. Well, this one should be a little easier because it starts me out with moles. And as long as I'm at moles, this is where I can do things with my chemical equation, so I don't need to do anything else. Now it says moles of product. I put HCl because there's only one product. Okay? I can leave it like this and just understand that it goes in my chemical reaction, or I can rewrite the reaction that it's 2HCl plus 184.6 kilojoules. So, either way, if I'm at moles, moles is going down here in the bottom, moles of HCl, well then I can go to kilojoules, and I can compare the 2 kilojoules and the moles. So it is negative 184.6 kilojoules being given off per, this time, 2 moles of HCl. I'm getting the 2 from the coefficient that's in front of the 2. I feel like I personally do a little bit better not to put these in the equations because I'm more likely to keep the negative on it. I'm more likely to lose it like I did earlier and then go back and have to add it. And if I calculate my numbers here, I've already done it, so with the magic of video, I'll just, pop out a number here. It's negative 523 kilojoules. I can answer it that way. I would also equally accept if someone put in words, 523 kilojoules given off. Those mean the same thing. You're telling me the given off by putting that negative sign on there. Alright. I have one more down here at the bottom, which says, given the following, calculate the heat evolved when 20 exactly grams, 20 decimal grams of methane is converted to carbon dioxide and water. Now, with this particular one, it's back like we did on the very first one. I've got grams, and I have to get to moles. So, if I do this, there's 16.0 grams of methane in 1 mole. And then I'm going to have methane again. There is 1 mole of methane for every 890.4 kilojoules given off. Now, I'm just not going to write the equation on this one to show you that I don't have to. It's the same idea. So, negative 890.4 kilojoules. If I work this out, my calculator is going to say negative 1,113, but I can have 2 sig figs. So, I can call it negative 1,100 kilojoules, or that's the same thing as negative 1.1 times 10 to the 3rd kilojoules. Or I can say either of those numbers. I can say, 1,100 kilojoules released, given off, generated, evolved. Somehow I can say in words the same thing that I have up here with negatives. You take your pick, but do one or the other.